For millennia, we've gazed up at the stars, wondering about our place in the cosmos. We've dreamt of reaching out, touching the face of the universe and bending it to our will. For generations, these dreams lived only in the realm of science fiction. But what if I told you that the future is closer than we think? Today we embark on a journey beyond the horizon, exploring the most audacious, the most mind-boggling space megaprojects ever conceived. We're talking about structures so vast, so ambitious, they dwarf our pale blue dot into insignificance. Imagine harnessing the power of a star, riding an elevator to the cosmos, or building entire worlds in the void of space. These aren't just flights of fancy, my friends. These are real concepts backed by science with the potential to redefine our future. But the path forward is fraught with challenges. Can we overcome the technological hurdles? Can we harness the resources? And most importantly, will we have the wisdom to wield this power responsibly? Join me as we delve into the thrilling and perhaps terrifying possibilities of space megaprojects. What if I told you we could build the impossible? Colossal megastructures bigger than planets, machines that could control the sun, cities that float in space housing millions. This isn't just science fiction, these are real concepts that could redefine our future. But here's the question, can we actually build them, or will they be our ultimate downfall? Buckle up, because this episode is about to blow your mind. Here on Earth, we're constantly scrambling for energy. We burn fossil fuels, we harness the wind and the tides, all for a tiny fraction of the power that bathes our planet every second from the sun. But what if we could capture it all? I'm talking about a megastructure so audacious, so ambitious, it makes even the pyramids of Giza look like sandcastles. Imagine a sphere built around the sun, encompassing its fiery heart and capturing every single photon of light and heat it emits. This, my friends, is the Dyson sphere, a concept first proposed by physicist Freeman Dyson. With a Dyson sphere, we wouldn't just be collecting solar energy, we'd be harvesting the entire energy output of a star. Think about that for a moment. The power to fuel our cities, our industries, our very civilization 1,000 times over. No more energy crises, no more reliance on fossil fuels, just limitless clean energy. It would be a technological leap, unlike any other, catapulting humanity to Type 2 civilization status on the Kardashev scale. But such power doesn't come without risks. Constructing a Dyson sphere would be a Herculean task, requiring unimaginable amounts of resources. We'd need to dismantle entire planets, perhaps even mine asteroids, to gather the raw materials. And then there's the engineering challenge of building a structure that can withstand the immense gravitational forces and solar radiation near our star. And what about the consequences of tampering with the very heart of our solar system? Blocking even a fraction of the sun's light could have catastrophic effects on Earth's climate. One miscalculation, one design flaw, and we could plunge our planet into a perpetual ice age. Or worse, the entire structure could collapse, unleashing a catastrophic solar flare that would incinerate everything in its path. The Dyson sphere is a tantalizing dream, but it's a dream that comes with a hefty price tag. A price tag we need to carefully consider before we even attempt to build it. Right now, escaping Earth's gravitational pull is a costly and dangerous endeavor. We strap ourselves atop gigantic rockets filled with highly explosive fuel and blast ourselves off the planet, hoping nothing goes wrong. But what if there was a safer, more efficient way to reach space? What if we could simply take an elevator? Imagine a cable stretching tens of thousands of miles from Earth's surface into space, tethered to a counterweight in geostationary orbit. Electrically powered climbers would ascend and descend this cable, carrying people and cargo into orbit with ease. No more expensive and dangerous rocket launches, no more limitations on who or what can go to space. The space elevator would democratize access to the cosmos, opening up a new era of space exploration, research, and even tourism. Imagine taking a weekend trip to a space hotel, gazing down at our beautiful planet from afar. The possibilities are truly endless. But before we pack our bags for our space vacation, there's a slight problem. We don't have a material strong enough to build the cable. This isn't your average construction project. We need something that can withstand the immense tension and stress of a cable stretching thousands of miles, battered by space debris and the Earth's gravitational pull. Even our strongest materials like carbon nanotubes fall short of the required strength. And if the cable were to snap, the consequences would be catastrophic. It would come crashing down to Earth, wreaking havoc on a global scale. So until we can develop super strong materials, perhaps something straight out of Star Trek, the space elevator remains a tantalizing but distant dream. Chapter 3, NeillCylinder, Building a Home Among the Stars. Our planet is facing some serious challenges, from climate change to overpopulation. What if our future lies not on Earth but in space? What if we could build our own self-sustaining worlds, orbiting the sun? This is the driving force behind the NeillCylinder, a concept envisioned by physicist Gerard K. O'Neill. Imagine a gigantic cylinder, miles long and miles in diameter, rotating slowly to generate artificial gravity on its inner surface. Inside, you would find everything you'd expect. On Earth, vast landscapes, shimmering lakes, bustling cities, and even artificial weather patterns. Millions of people could live, work, and thrive in this self-contained paradise. NeillCylinders could be our insurance policy, a backup plan for humanity in case things go south on Earth. They could also be a stepping stone to the stars, providing us with a platform to launch further explorations into the cosmos. But building an NeillCylinder would be a monumental undertaking. We're talking about assembling a structure larger than any ever built, requiring resources on a scale we've never even contemplated. We'd need to mine asteroids, perhaps even the moon, to gather the raw materials. And then there's the challenge of assembling it in space, a feat that would make the International Space Station look like a child's toy. And what about the potential for disaster? A single malfunction, a collision with space debris, could spell doom for the entire structure and everyone inside. The NeillCylinder represents the pinnacle of human ambition and ingenuity, but it also serves as a stark reminder of the immense challenges and risks associated with venturing beyond Earth. Chapter 4, Terraforming Mars. Breathing life into a dead planet. Mars, our rusty red neighbor, has captivated our imaginations for centuries. But right now it's a cold, barren wasteland, hostile to life as we know it. But what if we could change that? What if we could transform Mars into a second home for humanity? That's the audacious goal of terraforming. Imagine a future where the Martian skies are blue, where rivers flow and where plants flourish on its surface. We could walk on Martian soil without spacesuits, breathing freely in a new atmosphere. Terraforming Mars would be the ultimate act of planetary engineering, a testament to humanity's ability to reshape entire worlds. But how do you even begin to terraform a planet? We'd need to raise the temperature, thicken the atmosphere, and find a way to create oceans. Some scientists propose using giant orbital mirrors to reflect sunlight onto the Martian surface, melting the polar ice caps and releasing trapped carbon dioxide into the atmosphere. Others suggest seeding the planet with genetically engineered microorganisms that would release greenhouse gases and begin the process of creating a breathable atmosphere. But terraforming Mars wouldn't be a quick fix. It would be a multi-generational project spanning centuries, even millennia, to complete. And there's no guarantee of success. We're talking about manipulating complex planetary systems with the potential for unforeseen consequences. We could trigger runaway greenhouse effects, create toxic atmospheres, or even inadvertently wipe out any existing microbial life on Mars. Terraforming Mars is a gamble, a long shot, but it's a gamble that might just pay off in the long run. From harnessing the power of stars to building our own worlds, the possibilities of space megaprojects are as vast and awe-inspiring as the cosmos itself. These aren't just pipe dreams, they're grounded in science, driven by human ingenuity, and fueled by our innate desire to explore the unknown. But as we've seen, these ambitious endeavors come with immense challenges, risks, and ethical dilemmas. Do we have the right to tamper with the cosmos on such a grand scale? Are we prepared for the consequences, both intended and unintended? The future of space exploration isn't just about building bigger and bolder structures. It's about asking ourselves the tough questions, proceeding with caution, and ensuring that our reach for the stars is guided by wisdom and responsibility. Dyson spheres, space elevators, planet-sized machines. These aren't just dreams, they're our future. The only question is, which one will we build first? And in our next episode, we go even further. Can we leave the solar system? Can we escape our dying sun? Episode 7, Interstellar Travel, Humanity's Greatest Leap. Buckle up. This one's going to be insane. Like and subscribe if you'd live in space. Next episode, Interstellar Travel. Can we escape our sun?